Hello everyone, myself Vinay Kumar. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually explaining the concepts which are there in the 11th chapter of 9th standard science subject, which was on sound. So in this particular video and in my next video, I'll be explaining the exercises which are there in this particular chapter. So moving on to the exercise, before moving on to the exercises, we will look at examples which were given in this particular chapter. So there are two examples which were discussed in this chapter before. So I'll just explain those examples now. So coming to example 11.1 in this chapter, here they have given a particular situation where a sound wave has frequency. So this is the symbol for frequency, that is nu. So this is known as nu, that is equal to 2 kilohertz. So this is the frequency of the sound wave, and the length, the wavelength of that particular sound wave is equal to, so wavelength we denote with this particular symbol, we know that is lambda, that is equal to 35 centimeters. So this is the wavelength, and the distance which this particular wave has traveled is equal to 1.5 kilometer. So now using this particular data, you have to find out the time taken by this sound to cover that 1.5 kilometer distance. So we know that velocity is equal to, or the speed of a sound wave is equal to distance traveled by time. So if you just bring time to LHS and V to RHS, then T is equal to D by V. So here we need to calculate what is the velocity. Distance we know that is equal to 1.5 kilometer, and we have to calculate what is the velocity. So velocity is also equal to lambda by t. So this 1 by t can be written as frequency. So these things I have explained in my previous video, you can refer that. So v is also equal to lambda into nu, because 1 by t is equal to frequency, frequency is nu. So velocity is equal to lambda nu. Now you have lambda and you have nu. So using this you can calculate velocity, and using velocity you can calculate the time. So now we will call this as equation 1 and this as equation 2. So now in equation 2 we have got v is equal to lambda into nu. So v is equal to, lambda is 35 centimeter. So 35 centimeter means it is 35 into 10 power minus 2 meter, because you have to convert everything to SI units. So into nu is frequency, that is equal to 2 kilohertz. So 2 kilo means 10 power 3 hertz. So frequency is always measured in hertz. So 2 into 10 power 3 is there. So V is equal to 35 into 2 is equal to 70, and here you can see 10 power minus 2 and 10 power 3 is there. So base is same. So in both these cases base is same. So you can directly add the exponents. This also I have explained in the mathematics of 8th standard. So you can refer the playlist of my YouTube channel, and in that playlist you can select the 8th standard mathematics, and in that, in power and exponent chapter, I have explained about the laws of exponents. So here, since base is equal, you can add the power. So minus 2 plus 3 is plus 1. So into 10 power plus 1. So now 70 into 10 is there. So 70 into 10 is 700 meter per second. Now from equation 1 we have T is equal to D by V. So D is 1.5 kilometer. So kilo means again it is 10 power 3. So 1.5 into 10 power 3 divided by 700 meter per second. So you can write 700 in the denominator. So now if you calculate this, this is nothing but 1500 divided by 700. So here 0, 0, 0, 0 gets cancelled with each other. So 7 ones are 7, 7 twos are 14, point you can put. So 1 will be remaining. So if you put point, that will become 10. So 7 ones are 7. So 3 will be remaining 30, 7 fours are 28, 2 will be remaining, 7 twos are. So like this it goes on. So we can just consider 2.14 as the answer. So 2.14 seconds is the time taken by this sound wave in order to reach 1.5 kilometer distance. Coming to example 11.2 in this particular chapter, here a particular person claps his hands. So when this person claps his hands like this, he hear that particular sound after 2 seconds again. So that means this person has clapped his hands, and the sound what he has heard after 2 seconds, he is hearing the same sound again. That is, he is hearing the echo after 2 seconds. So what is the distance between that person and the reflector? So here they have given cliff. So here from the cliff the sound has got reflected and this person is able to hear that echo. So after 2 seconds he is hearing. So you have to tell at what distance that particular cliff is there. So that distance you have to calculate, the total distance between this person and that particular cliff. So in order to calculate that distance, here they have given velocity of the sound wave as 346 meter per second, and one more data they have given, that is time after 2 seconds is hearing that particular echo. That means the sound wave has traveled towards the cliff and it has traveled the same distance again back to the person. So 2 times it has traveled the same distance, then only this person is able to hear the sound. Now here, using this particular data, we know that velocity is equal to distance by time. So this time you can or distance you can keep it here itself, time you can bring to LHS. So Vt is equal to distance. So that is d is equal to v into t. So what is v? V is 346 meter per second. So 346 into t is 2 seconds. So this particular distance what we are talking is the distance traveled by sound. So this is not the distance between the person and the cliff. This is distance traveled by the sound. So how much distance sound is traveling? So that is d, which is equal to 346 into 2. So 346 into 2 is 692 meter. So this is the distance traveled by the sound wave, and we know that sound has traveled twice the distance because it has went to the cliff and it has traveled the same distance back to the person. So you have to divide this 692 meter by 2, then only you will get the distance between person and the cliff. So distance between person and cliff. So this you can call as D2. So that is equal to 692 meter divided by 2, that is equal to 346 meter. So 346 meter is the distance between the person and the cliff. So now we will start discussing the exercise questions which are there in this particular sound chapter. So coming to the first question in this particular exercise. So they have asked what is sound and how sound is produced. So here always remember sound is an energy. So sound is also a form of energy. This particular sound is produced when mechanical energy, so when mechanical energy of a particular body gives rise to vibrations. So when mechanical energy gives rise to vibrations, so these vibrations generate sound. So here basically sound is a form of energy, and this sound is produced when a particular mechanical energy is responsible in vibration of a particular object. So that vibrations produce sound waves, and your ear can detect that sound waves, and also there are so many other microphones which can detect the sensitive sounds as well. So basically here you have to explain that sound is a form of energy. So this particular sound energy is generated from the mechanical energy, and this mechanical energy gives rise to the vibrations, and that vibrations create the sound. So vibration of a particular object creates the sound. So this you can explain in your own words. Coming to the second question, here in the second question they are asking to describe rarefactions and compressions using a particular diagram and how these compressions and rarefactions are created around the source of sound. So you can roughly draw a particular diagram like this. So for example, if this is the source of sound, so let's say this is the source of sound. So this source of sound is generating the sound waves because of vibrations. So when this vibrations is generated by this source of sound, that vibrations of this particular object is transferred to the air molecules present immediately after that particular source of sound. And this air molecules experiences high pressure due to the vibrations. So that high pressure region of air molecules immediately after this particular source of sound can be known as, this particular region can be known as compressions region. Because air molecules are compressed due to the vibrations generated by that object, because of that vibrations, these air molecules around that source of sound gets compressed, and that region is known as compressions. And because that compressions region is created, there is less pressured air molecules present after this high pressured air molecules. So this is high pressured region. So this region is high pressured region. So this high pressured region can be known as compressions, and this compressions give rise to a low pressure region immediately after these air molecules, immediately after this high pressure air molecules. So this low pressured region, so this region is low pressured region, and this low pressured region can be known as rarefactions. So how these rarefactions and compressions are created? Because of the vibration created by this source of sound. So this particular source create vibrations at this region. So vibrations is created at this source region, and these vibrations are transferred to the air molecules which are present immediately after the source of sound and create high pressure region. Because of the creation of high pressure region, there is low pressure region immediately after high pressure region. So that low pressure region is known as rarefaction, and this high pressure region is known as compressions. Because there is transfer of vibrations from one particular set of air molecules to other air molecules, these compressions and rarefactions keep on moving throughout the medium. So the vibrations which is generated by this source has got transferred to the air molecules present around it, and the vibrations which those air molecules experience, that vibrations is again transferred to the next set of air molecules, and that next set of air molecules will transfer the vibration to the next set of air molecules which is there beyond that. So like this it travels through the air medium. So here particles are not traveling, the vibration generated by the source is moving through the air medium by creating this high pressure and low pressure regions. So that means after this low pressure region, again there will be high pressure region. After this high pressure region, again there will be low pressure region. So this goes on like this. So you can neatly draw this particular diagram and explain all these phenomena in your own words. For more explanation, you can refer my previous videos as well. Coming to the third question, why a particular sound wave is known as longitudinal wave? Sound wave is known as longitudinal wave. So I'll just write that sound waves are known as longitudinal waves. So I'll just write LW. So LW means longitudinal waves. So sound waves are known as longitudinal waves because parallelly to the direction of propagation of sound. So direction of propagation of sound. So coming to the fourth question, here they have asked, in a dark room, all of your friends are sitting. You cannot see them, but one particular friend is speaking in that particular dark room. Can you identify that particular friend by listening to his voice? Yes, of course you can identify. So now the question is, which characteristic of a sound is helping you in identifying your friend's voice. For example, there are so many other friends sitting in the same room. So everybody, if they are speaking, you can clearly identify your friend's voice. What characteristic of a sound is helping you to identify that? So that is frequency of a particular person's voice. Every person has certain frequency of his voice. So that particular frequency defines the pitch of the voice. So frequency always defines the pitch of the voice, and because of this particular characteristic of sound, you are able to identify your own friend's voice. So here pitch is the answer for fourth question. So every person has his own pitch for his voice. So that pitch is determined by frequency of the sound generated by that particular person. Coming to the fifth question in this particular exercise, here when you hear the thunder, before hearing thunder, you can see the flash of lightning. So why you are seeing the lightning first and then the thunder? So always remember, if you consider velocity of light, so velocity of light is equal to 3 into 10 power 8 meter per second, and velocity of sound at 22 degrees Celsius temperature, it is 344 meter per second. So this is velocity of sound in air. So velocity of sound in air at 22 degrees Celsius is 344 meter per second, and velocity of light is 3 into 10 power 8 meter per second. So that is almost 30 crore meter per second, or you can call this as 3 lakh kilometer per second. So that means here light speed is very much larger compared to the speed of sound. Even if the temperature is less, then the speed of sound will even reduce, because at the higher altitude temperature is even more lesser. So that means the speed of sound will become even more lesser, because temperature, if it is reduced, then speed of sound also reduces. So anyway, if we just keep 344 meter per second as the average speed of sound at 22 degrees Celsius temperature, that is still very less compared to the speed of light. So that's why you can first see the flash of light and then you can hear the thunder. So this is all there in this particular video. The next questions which are there in these exercises I will be discussing in my subsequent videos. Till then, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.